Okay, so as discussed, first thing that we'll be talking about is the process of garbage collection in .NET. So what this process is all about? It's a service provided by CLR that manages the allocation of the memory for your application and also the release or cleaning up of the memory for your application as well. Right? We discussed that on day one. Remember? Yes. Simply, whenever you create a variable or some object, some memory needs to be allocated. Whatever code we have written so far in last 3-4 days, did you notice that we never put some code which says that allocate this much memory? We just say I need the variable to be created or I need the object to be created. Nothing more than that done. Yes or no?
Yes.
So do you think without allocating the memory for variables or objects, the variables or objects would actually be usable? One simple example, you have joined Providence. If there is no laptop or desktop assigned to you, no machine assigned to you, would you be able to work? You guys have joined as a developer, right? And if there is no machine, how will you develop your code? How will you develop your applications? Do you need the machine to be allotted to you or not? Be quick.
Yes, yes, we do.
So, whenever we are talking about a program that is doing something on data, don't you think we need that data to be held somewhere in the machine? Then only it can be processed, right? If machine is not holding the data, how it can be processed? What do you think? It'll be a challenge, right? I have two numbers that needs to be added. A simple operation could be that. Until and unless the processor doesn't hold those two numbers somewhere, how the operation of add can be done on it? It needs to register those values or stores those values somewhere. We have CPU registers, which is actually a built-in memory of CPU itself, the processor chip, correct?
Yes, sir.
And that's where the memory allocation comes in. And now if we have got something allocated and we are no more using it, don't you think that needs to be cleaned up so that something else can use it? Of course, yes. Right? Some machine was allotted to me. My work is over with that machine. I'll not just keep on holding that machine. I'll just release it so that someone else can be allotted and that person can basically work on that machine, right? Such unused resources is called as garbage. Even when we talk about memory, it is the same thing. Memory allotted to you, you have used it, you have performed some actions. Now, you don't want that particular value anywhere. So you just, kill that object. Practically, you just release the reference of the object. That object still resides in the memory. Right? And that's where the garbage concept comes in. Now it is the garbage collector which keeps track of which object is in use, which is unused object. And if the application demands more resources, such garbage values can be removed and the claimed space can be made available to the application for the new requirement. And this is required because your memory is not unlimited or infinite. Correct? There is limited amount of memory available. Yes or no? Be quick, guys. Yes or no? Yes? I'm waiting for the answer.
Yes, sir.
Okay, so that's the whole concept all about. It is just about understanding exactly how the memory is allotted, how the objects are managed, how the tracker is set up and used by garbage collector, and then ultimately how the garbage collection works. Correct? So as we discussed in one of the session that your memory is available for the whole application, but the whole memory is divided in 4 different segments. One is called as stack. One segment is called as the most biggest segment is called as heap. And then there are two smaller segments once again. One is data segment. Data segment holds all static data. Code segment holds whole code. Heap holds all reference type objects. Stack holds all value type objects and the reference of the heap objects or the reference type objects. Like when I say int A is 32-bit integer. In stack, 32-bit block will be occupied, which will be labeled as A, regardless of its memory location. I can use it anytime by referring to A. By default, the value of 0 will be placed into it because it is integer. But if I say int A is equals to 10, or not this way, if I say A is equals to 10 on a separate line, that's where it will be updated. Okay, so stack contains the value directly for value types. This is a value type. Now, what happens with reference types? Stack is limited. I cannot put infinite amount of data on it or large amount of data on it. What if I have large amount of data? I have collection of employee objects. there are 1 million employees. How will I put that on stack? It won't accommodate. That's where I create employee class and whose instance I create this way. Employee EMP. EMP equals to new employee. It could be one single statement also though. Now what happens when I say employee EMP is a 32-bit block of memory is occupied on stack, which is labeled as EMP. Why 32-bit only? Because it is going to store the address of some memory location, which is always going to be a 32-bit integer. So 32-bit block is occupied and labeled as EMP. By default, what is stored here is null. Now, the moment I say EMP equals to new employee, somewhere in heap, the memory is occupied. Heap is unorganized, unstructured data storage. So wherever available, the memory is occupied, which contains, let's say, employee ID 101, employee name XYZ, and so on. Okay. Let's say the address of this memory location is 0x110011. This is what is going to be stored here in place of null. Now, when I say emp.id here, what happens? It goes to stack. It finds that there is a reference of some memory location. It goes to that, and there it finds ID where it is and reads it. Understood? Now, because in this case, the stack is storing the reference of the actual object, I mean, the memory address of the actual object, it is called as reference types. Understood?
Baba, 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 Baba.
Is it understood, guys?
Baba, Baba.
Value type holding the value of the variable directly in stack. Reference type holding not the value but the reference, the memory address of the actual object. Understood? Yes or no?
Yes, sir.
So you can differentiate between value type and reference type, right? Now, when I talk about garbage collector, garbage is always going to be in heap. Because here, if I say A is equals to 0, it will become 0. If I go out of the scope where this int was defined, it will automatically clear this. There will be no residue here. But when it comes to the reference types, here I said employee equals to new employee, but at some stage I can again say employee equals to null. In this case, this EMP will remain here. This will hold null. This will now remain with the residue in heap. This object is not yet removed. This object is not yet killed. This memory place has been reclaimed. Even if this EMP goes out of the scope, this EMP will be reclaimed. But the memory occupied on the heap will remain with the residue. It will not be claimed automatically. And this is This residue is called as garbage. Residual heap memory is called as garbage. Understood? Understood?
Yeah.
One common example I have, banquet halls, right? Where some functions happen. I hire a banquet hall. So that is an allotment to me, right? My function is done. I hand over the keys or whatever formalities to the staff. But after the function, there will be lots of stuff which will remain in the banquet hall, right? It was some corporate event, maybe just a meeting or something. There may be pieces of papers and the used water bottles lying here and there. If it was some other function with lunch or dinner as well, probably there will be used plates as well, right? I am not going to clear that. I will just say, okay, I'm done. I'm leaving it up to you. So that residue, whether it is used water bottles or glasses or cups or plates, whatever it is, that is something going to be your garbage. Yes or no? That needs to be cleaned up. If that space needs to be allotted to someone else, or can it be allotted as it is? No one would accept, no? It needs to be cleaned up. Yes or no? Yes or no?
Yes.
So that's the same concept applicable here. Okay. The whole GC process in .NET is actually based on the garbage collectors generation system, where the whole heap memory itself is further divided in 3 sections. So suppose this is the amount of heap memory I have. There is section 1 called as generation 0. Very small. There is next section called as generation 1, slightly bigger than this. And the biggest one with huge amount of memory available, we have third section, which is called as generation 2. Okay. Now what happens with generation 0? Technically, it is called as first generation. When it is used and what it does. Basically here, objects are allocated first. In other way, I can say new objects are allocated here. Understood? Second, most of the objects declared over here will be killed here only. They may not go forward to the next generation. So I can put this way. Objects don't often live past. If you have written the program properly in optimized manner, this point is going to be true. Objects don't often live past the first generation. Since they are usually no longer in use, or they go out of scope by the time the garbage collection happens. And then another point applicable is this generation is quick to collect because of its small size. Instead of quick, in fact, we can say quickest. Limited number of objects will be here. Mostly the local objects will be here. And once they go out of scope, they will be termed to be the garbage. And the garbage collection usually happens most of the time on generation 0. Once this generation has got enough space, the garbage collection need not happen on the other generations. Understood? So suppose there are several objects defined. There is object 1, there is object 2, there is object 3, there is object 4, there is object 5. All will be defined here. Understood? Yes or no? Till here, understood everything?
Yes.
Next is generation 1, which is technically called as second generation. Count wise, it is second, right? This is like a second chance space. Objects here also are usually short-lived. But are the ones which survive the first generation garbage collection. I'll put it this way, objects that are short-lived but survive the Gen 0 collection are promoted to Gen 1. Gen 1 means second generation. Okay. Gen 1 collections are also quick. I'll not say quickest this time. It's quick as the size is smaller here as well. They are quick, but not quicker than generation 0. Generation 0 is quickest. Reason why generation 0 and generation 1 are small, because most of the objects will either be garbage collected here, or if they are actually the long survived objects or long used objects, they will be promoted to the next generation. Right? Understood? Then comes generation 3, which is actually called as Gen 2. Technically, it is generation 3. Here, all long-lived objects are live. And hence, it's large in size. Understood? There is no next generation for further promotion of the objects. So this is quite huge. Usually this generation is reserved for some objects that are $85,000 bytes or higher in size. So big objects basically will land up here directly. Smaller objects may be there in this generation 2 if they have survived generation 0 garbage collection and generation 1 garbage collection also. Slowest garbage collection happens here. Understood? And is a blocking action. Your program has to halt when this garbage collection is happening. Understood? Because more and more processor resources need to be allotted. Get this done as quickly as it is possible. All the threads in the application are paused and the entire priority is given to the garbage collection here. Now, take an example from our day-to-day life. Whatever garbage that is generated during the entire day in our home, where it goes first?
A dustbin.
Smaller dustbins kept in house, right?
Yeah.
Every single garbage that is generated, as far as it is small enough to fit that particular bin, will go in that bin only, correct?
Yes.
But it is not unlimited, correct? There will be a time when it becomes full. When it becomes full, what happens? What is the next course of action?
A bigger dustbin in the colony, or
Probably some housekeeping staff comes and collects that garbage and puts it into bigger bin. Yes,
yeah,
that bin also is not unlimited. Definitely bigger than the household bin, but not very, very big. Correct?
yeah,
There is a limit to that also. Once that also becomes full and you need more garbage to be put in, what happens? The municipal corporation most of the time will collect this garbage and put it in some landfills where it will be processed further. Yes, and that landfill is quite huge. Not unlimited, but quite huge. Yes or no?
yes,
Usually somewhere in the outskirts of the city. Yes,
yeah,
typical same kind of three levels we have here. Whatever objects you have created goes here. Now suppose this is not having enough space and more objects needs to be allotted. The garbage collector thread will run and check which all objects are in use. Let's say this has went out of the scope. This has went out of the scope. This has went out of the scope. Object 2 and object 5 are still in use. They will be promoted to generation 1. Object 2, object 5. They are promoted here, whereas the memory for object 1, object 3 and object 4 will be reclaimed. And because object 2 and object 5 have been promoted, the memory for object 2 and object 5 in generation 0 also will be cleaned up. It's freshly allotted in generation 1, correct? So my generation 0 becomes empty. Do you get it? Do you get it?
yeah,
Here, the new allocation happens. Let's say object 6, object 7, object 8, object 9. Okay. And then the similar situation, more memory is required, which seem to be not enough in generation 0. By that time, I find that object 7 is no more being there in the context. Object is no more there in the context. They are removed straight away. Object 9 and object 6 will be promoted here. Yes, and the memory space here will be cleaned from generation 0. Understood? There are more objects coming in. Object 10, object 11, object 12, object 13, and we find that once again the space is no more enough and all objects are in use. None of them has gone out of the scope. Generation 0 garbage collector will just move all objects here. So I'll have O10, O11, O12, O13 all over here. Correct? And this generation 0 will be cleaned up. But I feel that the object which I'm defining cannot fit generation 0 still. I need more memory for it. Maybe that object fits in generation 1, but generation 1 seems to be full. The second level garbage chain will happen here. We'll find out which objects are not in use now. Let's say by this time, object 2, object 5, object 6 are gone out of the scope. Okay, something similar that we saw in generation 0 will happen here as well. The remaining objects will all be promoted to generation 2. So here I will have object 9, object 10, object 11, object 12, object 13, all will be moved here, and this generation 1 is cleared completely. Understood? And the new object is allotted here. Let's say that new object is object 40, which was big. There is another object, object 15, which is allotted. And the same cycle keeps on happening. The generation 2 garbage collection will happen when these two things are empty, but still there is more space required, and which is not enough available in generation 2 as well. Then the garbage collector walks here as well and finds out which all objects are unused. Let's say by that time this one is gone, this one is gone, this one is gone. So it will just reclaim the memory. This object will remain here only, here this object will remain here only, and then the fresh new object may be allotted directly here if it is a big one, more than 85,000. Maybe that is object 16. Understand? Understand how it works? Do you understand how the garbage collection works?
Yes.
Okay. Now, practically, we cannot force garbage collection to work anytime. Garbage collection is an automatic process, works on its own. Understood?
Yeah.
Still, there is a method provided here by .NET in an object called as GC. There is a class GC which provides a static method called as collect. What this method must be doing then? This method will just say at this moment the garbage collector can be used. This is just a suggestion, not a command. If system finds that yes, I don't have enough memory space, and as there is a suggestion in place, the garbage collector will run. But if system finds that no, I do have enough memory space available, there is no need of garbage collection at this moment, simply this call will be ignored or will be kept on hold. Understood? Understood?
Yes, sir.
That's all about the garbage collection process in .NET. Okay, there are a few things that you need to understand. Like constructors, the classes do have destructors also. So suppose I have a class called as person. The constructor is written like this, which may have parameters, which may not have parameters. There can be one or more constructors doing their job, right? Their job is to initialize the object. There are destructors also in the class. They don't have any access modifier. Their name always starts with a tilde sign, followed by the name of the class. They don't have any parameters at all. Here goes the cleanup code. Okay. These destructors practically are called by the garbage collector. You never call them, and you never know when they will be called. It is the garbage collector which will look into a specific object, whether that object has got a destructor or not, in order to help it with cleanup. If yes, it will be called. If not, it won't be called. But then, if your code is using some unmanaged code also, like something written in COM or C or C++ language being called here, in that case, the class will be required to inherit, in fact, implement an interface called as iDisposable. Because while working with unmanaged code, we will mandatorily require the unmanaged resources to be released forcefully the moment the object is not being used anymore. Because otherwise we may end up with memory leakage. So when we implement this interface, the class needs to have a method called as public void dispose created into it. Doesn't take any parameter. Here also there is cleanup code, which is mainly written for unmanaged resources. I can specify cleanup code for unmanaged resources. Mainly. Now, because the cleanup has happened over here itself, ideally, this destructor should not be called again. If I don't do anything here, the destructor will be called again. There will be two-time cleanup happening. So for that reason, usually after writing our cleanup code in dispose method, we do call gc dot suppress finalize, as destructors are called as finalizers in .NET. So when I say gc dot suppress finalize is called, the destructor will not be called further. It is this dispose method only that will do the job. And this dispose method is not called by garbage collector. This needs to be explicitly called. We have to call it right where the object is no more required. We say object.dispose explicitly. Do you get it? And because we have cleaned up everything for that particular instance, the finalizer need not be called because it may fail. It may fail with exception. It will try to kill some object which is already killed. So that's an exception. That is why this gc.suppress finalize is mandatory. Whenever you are using dispose method with iDisposable interface being implemented. Understood?
Yes.
Okay, now let's talk about the parallel programming. Okay, so can you quickly tell me what kind of processor your laptops have? One or two people can just check and tell me. I need few things like brand, processor type. Within brand also we have types, right? Like one example is I may have Intel processor, that is the brand, and type might be either i3 or i5 or i7 or i9, maybe Celeron, maybe something else. Pentium dual core, Pentium quad core are also there, little cheaper ones. Brand can be AMD, and there also we have different chip types, correct?
So it's an i7.
I believe it must be the same configuration for all of you, right?
It's an i7 10810U CPU at the rate 1.10 gigahertz normally and 1.61 gigahertz turbocharged.
Yeah, so most important thing over there is you have i7 CPU. Okay, now can you right click on your taskbar and go to Task Manager? Within Task Manager, go to the Performance tab where you see various components of your machine here, and then right click on CPU here and say, in fact, on right side, this grid which is getting showed, just right click on that and say change graph to logical processors. You will find that one rectangle getting replaced with multiple rectangles. Can you guys tell me quickly how many such rectangles or squares you see there? 4,
8.
6, 8, 16. Is it same as mine?
Yeah.
I have another laptop with me which has got 16 such boxes displayed when I come here. What do you understand by this? What is this box?
Core.
Yes, each box represents a logical core. Correct? Now, what do you understand by core? When the personal computer thing was created, in fact, when the computer was created, there used to be one processor, one single processor, within which only one thread was allowed to execute at one time. That's why we had algorithms like time slicing, round robin, and all. And this whole thing was managed by OS, correct? So even if your computer is multitasking, multi-threading enabled, at any given instance of time, only one single piece of instruction can execute, which is what we say single-threaded execution. And the switching between the threads is so fast that it looks like everything is working together. Yes or no? Yes. This continued till Pentium 3. Even the earlier versions of Pentium 4 also had the similar architecture. Then Pentium 4 with HT technology came in. When this HT technology based processor was introduced, the processor still remained one single processor only, but it allowed two threads to be executing simultaneously. For that, what they did is they divided one physical core of the processor chip logically into two, because technically only one thread is possible even today to be executing in one core of the processor. So software level handling was done, or software level configuration was done to make it simulate as if there are two CPU cores there. Though there was only one physical core, the simulation of two CPU cores allowed two threads to be working parallelly. So even if your processor speed doesn't increase, still overall processing can be achieved more quickly as there is more work happening in parallel? Yes or no? Yes or no? If one person doing a job, let's say there is a job of digging a well, only one person is digging. Let's say it's 10 meters deep well we need to dig. Just compare this task with two people doing that digging work, which will be completed first. Single person doing the digging or two-person doing the digging. Tell me quickly.
Two persons.
Of course, even if one of the person is little slower, still the task will be completed more quickly if two people are doing it, right? Agreed?
Right, sir.
That's what Pentium 4 with HT brought in. Basically, there was just one processor chip. Then came Intel Core 2 Duo processors. I mean, Pentium 4 was advanced with Core 2 Duo. What was different here? They actually made one processor which actually had two physical processor chips into it. Assembly was one. It looked like one processor only. But inside that one processor, there were two chips physically present. And each chip allowed one single thread to be running into it. So here, if I see logically, P4 with HT and Core 2 Duo seem to be the same. Yes or no?
Yes, sir.
Still, there was a difference. This was logical division. There was some software controlling this too. And to control this at the software level, don't you think that software component also needs to run in the processor? That component might be eating up some time of the processor. Yes or no? Either this logical core or this logical core, or maybe both partially. The overall time required here would be little more. Here I have physical distribution. There is no software controller in between. There is hardware controller. There is no additional work that needs to be done here. So naturally, this setup will be faster than this one. Diagram wise, though it may look the same, but still there is a difference. Yes or no?
Yes, sir.
It's like here there are two people, but the second person is working when there is a third person who is giving commands. Okay, now dig, now stop, now dig, now stop. In this case, the two people are working totally independently. One started, they both start. And if the command for stop is received, both of them stop. It's more good. It's going to be more faster. Yes or no? Next advancement was Core 2 Quad. Where one single processor was actually divided in 4 physical cores, which means I was able to run 4 separate threads physically. And this was later on replaced with i3, i5, i7 and the latest one being i9. They follow the similar structure. So when you say I have a quad core processor, actually I do have an assembly like this. But then if I talk about i7 quad core, like what we all have as of now, the case is you have 4 physical cores and each core further is divided in logical cores here. So totally how many logical cores you are getting here? Which also answers how many threads I can run simultaneously. One here, 2, 3, 4, 5, 6, 7, and 8. If it's a octa-core processor, it may have 8 physical cores, and octa-core processor with hyper-threading, if it is enabled, I will have 8 into 2, 16 logical cores available. So here, if you see, it shows me the boxes are 8, so it looks like 8 cores are there. But if you watch this area, it says I have 4 cores only, but logical processor count it shows 8. What it means? It means I have an assembly that matches this. 4 physical cores, where each core is further logically divided in 2 logical cores. That makes it 8. Understood? Understood? So 4 physical core means what? I actually have 4 processors in my machine and 4 physical cores with hyper-threading enabled. I have the power of 8 logical processor cores. 8 threads can run together at once. Do you get it? You might have seen in last 10-15 years, the speed of the processor, the clock speed has not increased much. It's still hovering between 2 gigahertz, or rather I would say 1.5 gigahertz to 3.5 gigahertz. Yes, because if that speed is increased further, the processors will start up heating and will melt, damaging the system. That is why the engineers basically looked for some different approach where they assembled the low processor clock speed based chips, multiple low clock speed based chips into one assembly. So though you might be purchasing one processor, but that processor actually is just the assembly. Inside it, there are 4 or 8 or 16 different processors installed. To make it easy for you to do the installation, and again, we are going with the compact devices these days. Basically, they have assembled it in one single hardware device. Okay. Well, let's not get into the hardware part. Let's understand the concept. We have very, very powerful processors which can run multiple threads together at the same time. Yes or no? Now tell me whether just getting a processor with more cores or more logical cores is good enough for us to get best performance. And we don't require anything else. We have purchased a mobile phone with octa-core processor. Is that enough? Do you think all programs will work well and will leverage multi-core processor system? Tell me quickly. It's as good as if I am the team leader and have got 8 team members within my team. Okay. One of whom is little older within my team. I know him or her very well. Capability also, I have confidence in. So what I do is, whatever work comes to me, I allot all the work to that person only. The rest of the 7 people are just not being utilized at all. Would it be the efficient, optimized solution? Yes or no? Please answer. Forget about this hardware thing. I just asked a simple question from real life. I have 8 people in my team. I'm giving all the work to just one of the person. Will it be providing me the highly efficient and optimized solution or not? Yes or no?
No.
One person, no matter how much capable he or she is, can do a limited work only, right?
Yes.
If I divide that work across all the team members, maybe some of them might be taking little extra time, maybe newcomers, so have less experience, and uh, they might do the mistakes as well. But still, overall situation, if you look at, don't you think if I divide the work in all the team members, my job can be completed more quickly?
Yes.
That will be a more efficient and optimized solution. Yes or no?
Yes.
So what I should be ideally doing? See, when you purchase a heavy configuration processor, whether it is for your desktop or laptop or mobile phone, that's not enough. Sometimes you might feel that in your mobile phone you have octa-core processor, but still some of the applications are very slow. I hope everyone must have noticed this at some point in time with some or the other application. Yes?
Yes.
Yes, sir.
Why that happens? The reason is simple. The developer of those applications have not written the code to utilize this capability. They have not written the code in a way where it can be broken down and distributed to multiple processor cores for parallel execution. Their code is going in one processor core only. Understand? Some applications
Yes.
work really nice, some applications lag. So you can now understand why it happens. Yes or no?
Yes.
So what needs to be done? If I am looking to leverage from this capability of the processors, see, this is also applicable when my machine actually has got 2 or more physical processors installed, which is usually the case with server machines, right? Motherboards may have the support for 2, 4, 8, 10 processors being put together. They may have multiple sockets for the processors, right? So there also this may be required. So we have to write code which takes advantage of this hardware capability. Does that mean I need to do hardware level programming? Initially, yes, it was the case. But these days, most of the frameworks, including .NET framework, does provide some capability pre-implemented into it, which then interacts with the hardware to distribute your code on multiple processor cores, either physical or logical or both. So you need not worry how I interact with the hardware, how I schedule my application task on different logical cores or something like that. It is your framework which will take care of it. You just tell, this is my code which can be broken down, which can be run in parallel. Once you give it, it is entirely the frameworks and operating systems job to actually distribute it on multiple cores. Do you get that? Yes or no? Okay, so here we will take a break. Once we come back, we will see the implementation of some code features, some language features, where our focus will be on understanding how the multi-core processors or multiple processors can be used for our own advantage here to make our application perform better. Yes? Okay.
Yeah.
So we'll be resuming at 2:15, 2:15, and we'll see the implementation of parallel features in .NET and in C# language. Okay, so see you at 2:15. I hope you understood the concept because that will help us understand the implementation easily. Yes?
Yes.
Yes, sir.
Okay, so see you at 2:15, 2:15.